Hi everyone, welcome to Black Hat Europe 2021 Arsenal. I am Tushar Kulkarni and I am going to present VAPI, which is a vulnerable lab. APIs have been gaining much popularity these days due to their resourcefulness in architectural design. Though we have seen a lot of breaches happening worldwide, and it may be due to one bad misconfiguration in APIs. However, we have also started considering API security as a separate thing, or including APIs separately in the security processes that we do, be it vulnerability assessment, penetration testing, or even a DevSecOps pipeline. VAPI is a small attempt at spreading awareness about API security. Before we jump right into what VAPI is, a little bit about me. I am Tushar Kulkarni. I come from a small city in India called Wardha. Currently, I am working as a security research engineer at Home Security. I focus on vulnerability assessment, researching latest vulnerabilities, and implementing tests to detect those vulnerabilities in customer environment. I have also been leading the OWASP Nagpur chapter since 2018. I strongly believe security is for everyone, and the more people get to know about it, the more secure projects and products are built. I have also contributed to Vinja CTF at Nalcon, which is an event that encourages and promotes women in security. Previously, I have given talks and trainings at OWASP AppSec Days, local OWASP events, IEEE chapters, and hackathons at large. You can find everything about me on roottusk.github.io. VAPI is a vulnerable lab or exercise platform where you can learn about API security. It demonstrates API vulnerabilities in gamified way. So if you have just started as a penetration tester or a security engineer who mostly focuses on offensive security, it may help you get familiarized with the categorization of API vulnerabilities. The lab will also allow you to learn the very basic vulnerabilities that you may come across in REST APIs. And if you are a developer, you may get to have a look at a very bad and vulnerable code that I have developed. So it can remind you not to repeat the mistakes that I have done intentionally as a part of the project. And since we are already looking at the code, I hope it tickles your imagination on mitigating those vulnerabilities too. For technology stack, we have used Laravel and MySQL. Laravel, of course, as the primary framework for APIs, and MySQL as a database. Since PHP is a good language to articulate vulnerabilities and Laravel allowing us to create APIs by enabling the MVC architecture, we have chosen Laravel. Earlier, it used a LAMP stack which involved PHP and MySQL, but that version didn't quite follow the MVC architecture. Hence the name Adversely Programmed Interface and not Application Programming Interface. Setting this up can be a bit long and tricky for some people, so we have Dockerized the whole project, which can be spun up readily and quickly. We also have a PHPMyAdmin interface that runs as a part of Docker service, so you can easily troubleshoot what is going on in the database. You can install and set the VAPI lab in two ways. One is the Docker way and the other is manually. For Docker, you should be having Docker Engine and Docker Compose binaries on your system. Then you can simply go to the root of the project and run a Docker Compose up daemon, which will start all the necessary services. For manual installation, you need to have PHP and MySQL installed on your system. Generally, PHP 8 and above works fine. Similarly, you can also configure your MySQL credentials and the server port in the .env file of the project. The .env file should be ideally located under vapi/directory. You can then run the php artisan serve command, which will start the Laravel server. For documenting API calls, we have Postman collection and environment that can be imported quickly into the Postman tool. It also has necessary test scripts as a part of API calls that execute automatically when you send a request. So the token generation part is taken care of by these Postman scripts. We are also planning to migrate or make it available in open API documentation or architecture due to portability reasons. And you can also do a pull request to the project. For testing advanced attacks, you have MITM proxies such as OWASP Zap or Burpsuit. Some API vulnerabilities like credential stuffing may require you to run an intruder or a Zap script to solve the challenge. Hence, these tools can be useful and handy. The VAPI project is entirely based on OWASP API Top 10 project as of now, which was released as its first version in 2019. OWASP API Top 10 projects lists out top 10 vulnerabilities occurring in API. You may see the vulnerabilities like injection at 8th position and broken object level authorization and broken function level authorization above it. Since APIs have a different set of occurrences of vulnerabilities as compared to web application. A huge thanks to this OWASP project which enabled the development of VAPI. You can check this project on the mentioned link. And like I said earlier, APIs have been gaining popularity. The primary reason I believe is the platform independence. APIs that you have developed help deliver rich services and can be seamlessly consumed by any type of front end. Let's say it's a mobile, a web UI, or even a desktop application interface. And that is one of the reason that makes API security the new cool. Platform independence, like I discussed. APIs are also like a core part of the business logic, meaning if you are using an API, chances are that it might be your primary code. It is also a major part of modern web application these days. Gone are the days when dynamic data was only loaded on a web page after a refresh. And we have come a long way now and seen new frameworks making asynchronous calls to APIs and updating dynamic data on the fly. This is a great UI and UX breakthrough that has happened, which has enabled the usage of APIs. We have also seen automation being implemented on a large scale in most of the industry, and here API acts as a crucial part. I would also like to discuss on how vulnerabilities in APIs differ from vulnerabilities in web applications. In web applications, we get to see cross-site scripting vulnerabilities in the wild, but that's not the case with APIs. You are less likely to find a cross-site scripting vulnerability in API, given that the content types are properly managed and can't be manipulated by the attacker, or unless the data consumed by the front end is not encoded during the display. On the other hand, we see a lot of broken access control and broken authorization vulnerabilities in APIs. For example, a misconfigured JWT token or an insecure direct object reference that allows you horizontal or vertical privilege escalation. We get to see a lot of such vulnerabilities. Then there is cross-origin resource sharing misconfigurations and ways to bypass it that allows attackers to steal data. A lot of breaches have happened through these kind of vulnerabilities in the past. Organizations that heavily rely on DAST scans would have hard time assessing the API because testing API requires a lot of different context as compared to web applications. For years, I believe the improvement has been made in the DAST tools with perspective of a web application. Thus, DAST engine may have a hard time comprehending and enumerating APIs. These are some of the milestones and roadmap of the project. Laravel migration is something that is still in progress, I would say, but mostly it's done. We also aim to create a dashboard for users where they can submit flags. And so this gives them a sense of accomplishment. And the third one is something that I see as a long-term goal, that VAPI being a crowdsourced playground for the API security. So people can come up with new scenarios of vulnerabilities and contribute to the project. So this helps learn everyone. Now let us have a look at one or two examples from VAPI. This is my Postman tool, and I have already loaded the vAPI Postman collection and the environment. The environment has the domain name already set on which my vAPI service is running. The test scripts generate the authentication token or the API key automatically, so you don't really have to go and edit the environment. I will set up an MITM proxy to my burp suite, which is also running. So I'll just turn the proxy on. Let's have a look at API 6, which is mass assignment vulnerability. So I hope this request is creating some kind of a user. So we will just give our name. Let the username be root-task2. And we can set a dummy password like QWERTY123. Now let us send the request. So our user is created and the ID is 2. I hope it is automatically set in the environment. Yeah. So we have an authentication token that is automatically set. The test script here automatically set that API key. Now we can use the next request, that is get user. I hope it's probably to get whatever details we have registered as a user. So let us send the request. Now it says ID2, name Tushar Kulkarni, and username as root-task2. But we have one more parameter, that is credit, which is 0, and that might be the default value that is generated when an account is created. Now, since this is a mass assignment vulnerability exercise, let us create another user and try adding the credit by ourselves and see if we get any. Let's add something like 1000. And yeah, let's send the request. So now the ID is 3. I hope the authentication key is automatically set. Now let's try and get the details that we have given to the server. But this time we mentioned the credit explicitly while sending our request for creation of user. So yeah, we got our credit. We could successfully override the credit that is by default set by the server. And we have also got the flag. So this means that we have successfully exploited the mass assignment vulnerability. I would also suggest you to check out other exercises as a part of this Postman collection or the project, which would help you get to learn more about other API security vulnerabilities. We also have a documentation page on the /vAPI endpoint, which you can see. It describes the challenges and gives some sort of hint. So as part of API 1, you can see it says you can register yourself as a user, or is there something else? So this is kind of challenging you to solve the API security challenge. You can also use burp suite as a MITM proxy for sending requests. So this can help you, carry out advanced attacks like intruder, or maybe try and decode some data that you are getting as a part of response. So you can use this. That was all about the demo. I would suggest you to check other challenges as well. Huge thanks to all the contributors of this project: Paulo, Mohit, Chaitanya. Especially Chaitanya, he helped with the mobile application part. Thanks to APIsecurity.io too, who published vAPI in their newsletter, so it could reach to a larger audience. A big thanks to mentioned link maintainers as well: Mind API, OWASP VWAD, Awesome API Security, for considering including vAPI as a useful resource for learning API security. These are some of the references that I've used, and you can check. Thank you all for attending my talk. Please drop your questions in the chat box if you have any, and I will be happy to answer. Or you can reach out to me on @vk_tushar on Twitter. Thank you all.